I get excited about product. And so I'm like, yeah, this thing's amazing. It's super compliant. It's going to be awesome. And then you're like, so our goal was to eliminate as much hand pump as possible. While at the same time, not making a noodly bar that just feels kind of vague in your hands when you're riding. It's a very popular post. We want to keep it that way. You can take out every bolt from this post, turn it into a pile of base parts using only an EDC tool, which I think is pretty cool. One of the things we try to do here is not just enter the market with what we call Me Too products.
Jon Staples, welcome back to the Downtime Podcast, man. How's things with you?
Going really well, Chris. Thanks for having me back.
Good. It's always a pleasure. I like to catch up on anything when it comes to a bit of product design. Before we get stuck into things, though, just remind people what it is that you do within the OneUp family.
Sure. I've been here for just over 10 years. I was one of the original 3 founders here at OneUp. And I'm currently the Chief Technical Officer, which pretty much means that I'm head of product design. So I'm here to talk about products.
Excellent. Sounds good. And we chatted, I think it was back in 2021 now, we recorded an episode with yourself and one of your fellow founders where we talked about the kind of growth of the business from basically a 42 tooth expander sprocket was kind of where the whole thing came from. And it's expanded from there literally into an awesome product range. People can go and check that out over on the website downtimepodcast.com if they want to hear the full backstory. But a lot's gone on since 2021, hey? Like both in the industry and for OneUp, like your product range has grown pretty substantially.
Absolutely. COVID hit us. I think we've doubled in size since then. We're now 29 people here in Squamish. Our entire corporate structure is based here in Squamish. So we ship worldwide. Yeah, we're growing.
Yeah, it's good to hear, man. Well, I wanted to start off by chatting a bit about handlebars. I think often like a bit of an underestimated part of the riding experience. It's what connects us into the bike. It's what enables us to steer the bike. And there's a lot of intricacy in both design, the shape, the way the bars are made. But I think a lot of people are just like, well, that looks like a nice bar. I'll grab that one kind of thing. And it fits my price range and all this sort of stuff. But you guys entered the handlebar market and you took a bit of a different approach. I think it began with a carbon bar. Is that right?
It did begin with a carbon bar, yeah. One of the things we try to do here is not just enter the market with what we call Me Too products, which means we're making a carbon bar too, and it's made in the same way, in the same fashion, and it has the same performance as other people. So we try to find ways to differentiate ourselves from the start. On the carbon handlebar, which was the first one, and on our current aluminum bar, what we did in that case was to make the section between the clamping section and the control section an oval, so that you get a bit more compliance vertically when you're ripping down the trail and your hands are moving. You want to try to eliminate hand pump as much as possible, because hand pump leads to sore forearms, which leads to a lack of being able to brake. And I firmly believe that if you lose your ability to brake, you lose your ability to go fast.
Yeah.
So our goal was to eliminate as much hand pump as possible. While at the same time, not making a noodly bar that just feels kind of vague in your hands when you're riding.
Yeah, so you're looking at trading off. Well, I guess you're not really trading off. You're trying to separate the vertical compliance that you want to take the vibration out of the hands away from the stiffness when you're turning the bike effectively. Is that what you're saying? You're decoupling exactly. To an extent.
Exactly. Yeah.
Yeah. Okay.
Yeah,
Sorry, go
ahead. I was going to say that we spent quite a bit of time in a few prototypes. We did carbon first because it allows you kind of unlimited shape opportunities. You can make the mold whatever shape. So we did various SLA parts, even though it's not full stiffness. You can kind of still get an idea.
Mm-hmm. What's SLA for people that aren't familiar with that?
SLA is stereolithography. It's a type of 3D printing. Uh-huh. So you can make an actual bar in full form, and even though that material is very weak and very flexy, you can still get an idea of how stiff it is in comparison to other parts that are made of the same material.
Okay, yeah.
So that's where we started, and then we picked our best option for that one, and moved forward with a an actual carbon tool, and then iterated the layup from there.
Yeah, I was going to say, is all of this like compliance element of it from the geometry of the tube section, or is there a significant element of like the carbon fiber layup as well?
There is a significant amount from the carbon fiber layup, but you can only do so much when you're hampered by geometry. So typically bars are a round section at the stem, a round section at the controls, and then a tapering round section between those two pieces. And so if you need to make a bar strong, which you do, most of the material that contributes to strength, both in tension and compression, comes from the top and the bottom of that section of tube. And so with carbon, what you end up doing is having very thick, in a circular cross section, you end up having very thick top surface and a very thick bottom surface. And then to get your weight down to where your target is, you end up with very thin front and back surfaces. And what that gives you is actually the opposite of what you want, which is stiff up and down and flexy front to back. So by using geometry to our advantage, we made that section oval so that it's quite short top to bottom and quite long front to back, which allowed the layup to be more homogeneous wall thickness all the way around that oval, which also helps with layup, also helps with molding, because then you can wrap your sheets completely from the top all the way around the surface, and you get more long fibers going around the entire circumference of the oval, which makes a stronger bar in the end as well. So by not having these really thick top and bottom sections and these really thin front and back sections, we were able to make both a stronger bar and a more compliant bar without adding a bunch of extra weight. So it ended up being, from theory to practice, actually worked out really well.
Yeah, and having that more homogeneous layup, does that help reduce manufacturing cost, or does it just improve kind of piece to piece robustness? Like you've got less risk of a part being, to a high end of spec kind of thing.
Yeah, I think we've all seen those images of like a bike frame deconstructed into all of its carbon fiber pieces. Like you see that in when people launch new products. And the reality with carbon fiber is it usually takes a lot of small pieces put in exactly the right spot. So by allowing that carbon to wrap all the way around the post, you end up with larger pieces, less chance of missing a piece, or the tolerance of the material adding to a larger tolerance in weight range of the part. So it just makes manufacturing easier. It makes the parts more consistent, and it makes the ride feel better to the end consumer.
Yeah. So is there any trade-off then in compliance and strength? Because obviously they're two things you want to achieve. Can you, as you increase the compliance of the bar, are you therefore naturally reducing the strength, or is the fact that you've done this more through geometry kind of combating that trade-off?
Exactly, it does combat it. So strength is a given. We have targets that we need to hit. Our carbon bars pass Zedler ASTM 5, which is a high-end DH standard. So even though we have an aluminum bar that is for other reasons more suited to DH, our carbon bars do all pass the highest, most stringent standard, well above ISO. So strength is a given, and then it's how much compliance can you get without dropping below that strength target. And geometry was really the answer to be able to do that.
Okay, interesting stuff. So what testing does it go through then once you've decided on what you want to achieve and you've got some prototypes, and then you've got some parts to go and test? I guess there's a durability element to this, but there's also like the ride feel element and trying to get that compliance right. How do you
Absolutely.
get from early prototypes through to a signed off product into production?
As much as carbon's really awesome to work with, because you can do a lot with the mold. Once the mold's cut, that outer shape is kind of set without cutting another mold, and they're fairly pricey. So so you take your best shot at a mold you think will work, and then you iterate layup from there. From there, you are testing. In our case, we tested compliance, so we benchmarked it against popular bars on the market. we found that we had an advantage both in being able to be more compliant as well as stiffer in the steering direction.
Okay.
We get it on test rider bikes. Everyone here at OneUp rides bikes. So we do a lot of internal ride testing here in Squamish, but we also, and then we send it off for third-party testing. In the case of our current bars, we use Zedler testing in Germany. Uh-huh. But we're also toying with EFBE, which is another one of the above ISO standards. Everyone talks about ISO in the bike industry, and it's kind of the minimum that you need to hit to be able to sell a product. But I think it's well understood, especially for handlebars, that passing ISO is a fairly easy target and not sufficient to sell a product on the market.
Yeah, the stronger the better when it comes to a handlebar. No one wants that break.
Yeah, exactly.
To be fair. And when you talk about like internal ride testing, there's loads of you there with bikes and you're all going out testing stuff. How does the feedback loop on that work? Like, do you come back and fill in a form after your lunch ride when you've tested something? Like, how do you kind of communicate?
A little bit. In the past, it was a bit less formal than that because we've been growing, and when it was just the three of us, we'd get prototypes and go ride them and be like, "Yeah, that's awesome." As we grow, we're now 29 people. Our engineering manager Nick takes care of our internal and external test riding program. Mm-hmm. So people sign up for these products. They give us regular feedback. And I should stress that we never put anything on a test rider bike that hasn't already passed test lab testing.
Yeah,
it's not a guinea pig scenario. It's a this thing is safe, but do we like it?
Yeah, okay.
Kind of test riding application.
Yeah, and how does that work though? Because it's quite something like compliance, vertical compliance in a handlebar is quite subjective. It's very hard to come back and say, well, that was a score of blah blah blah.
Yeah, absolutely. And it is very subjective. It's also highly dependent on the grips you ride. Like if you run a thinner pair of grips, you're going to be more in tune with the compliance of your bar, where if you run a thicker set. So from our test riders, we're more looking for did you like this better than the product you were riding before? And specifically with compliance, I find this in bike frames as well. It's very difficult to tell when you go to a more compliant product, but it's very, very noticeable when you then switch back to the product you had before. Mm-hmm. So I find going to something that is stiffer is more noticeable to a rider than going to something that's more compliant. So we ask them to put it on, ride it for a bit, and then put back what you're running before and see what you think about that.
So there's like an ABA test where you go back to your baseline to remind yourself kind of thing. Because it's harder unless you're at the trailhead and you've got a mechanic there and you can do quick swaps. It's not always straightforward to just switch handlebars halfway through a bike ride.
Yeah, absolutely. We've tried doing that. We've tried like a short set course and then having bars swapped out and having them kind of wrapped so you couldn't see what you were running. Okay. And it's a lot of effort. At the end of the day, people want to go ride the trails that they love, not the random trail we pick up. So you send them out with a bar, you get them to swap it back to something they had before, and you can get some pretty good feedback.
Yeah. Do you try and keep at least a portion of that testing blind effectively? So maybe it's not like covered up, but you don't tell them that what you're trying to achieve with it. You're not saying we're hoping this is more compliant. You're just giving them a bar going and saying, go see how that is.
We do that more externally. It's hard to keep secrets internally where I get excited about product. And so I'm like, yeah, this thing's amazing. It's super compliant. It's going to be awesome. And then you're like, don't tell the person what it's about. And they're like, I already know, man. I already heard you talking over at the lunchroom and through the wall. So it's hard internal, but externally we certainly try to keep a bit of wraps around what we're trying to achieve and what feedback we're hoping to get, so that we don't soil the feedback that we do get.
Yeah. And do you test externally with like a varying level of rider ability, or are you more interested in like high-end riders and their ability to feedback?
We focus more, I would say we focus more on high end, and probably not because it's not that we don't want the lower capability riders testing. It's that the high capability riders typically test more. Uh-huh. So we have guys that ride every day. And you typically get more long-term feedback from those riders.
Yeah, in a shorter time period, I guess.
In a shorter time period, for sure.
And when you're trying to develop and get things into production, then anything you can do quicker is of benefit, I guess.
Absolutely.
Yeah. Okay. So you've got this this bar. You're happy with it. That goes on sale, and then you followed up with an e-bike version of the carbon bar. And there's definitely a level of skepticism around like e-bike specific stuff, I think, within the market, and whether it demands it or not. It's certainly in some cases. But what do you see as the differences, or what have you made different with the e-bike bar? Is it purely down to just having cutouts for the control cables, or is there more going on from a technical perspective?
It's 90% the ability to clean up the cockpit. So with the e-bar, we introduce grooves that allow the motor controller to turn back on itself and go underneath the grips, go through a hole, and then travel all the way down the bar to the stem, instead of having to externally tape that cable onto the outside of the bar. We did take the opportunity to try to improve the compliance. On the e-bar, we rotated that flex section slightly back towards the rider. And the goal there was that the forces that your arms put into the bar aren't vertical. And our original bar isn't vertical either, but we rotated it back a little bit further so it's in line with the arms. So as your arms are pumping down the trail, pumping the bars, they're actually in line with that thinner section. So it gives more of the compliance back to the rider instead of kind of hitting the compliant direction at an angle.
Yeah, that makes sense. Yeah, totally. What about like the whole strength stuff? Is it all still the same targets for an e-bike for you?
We have it. There is an ASTM 5 plus e-bike, which is what that current bar passes. But at the end of the day, as we develop more products, we're going to be testing to that e-bike standard, because most products outside of that particular one having slots for cables. E-bikes are just bikes that are a little bit heavier. So if we're going to sell products for bikes, they need to be products that we can put onto e-bikes regardless what they are. Yeah,
definitely. That makes sense. So carbon bar done, happy with that. Set out to try and do that in aluminium. And I've got a little bit of a background in engineering, and I'm guessing that was substantially harder.
Yeah, absolutely. One, because you're a little bit more limited on what you can do with aluminum, short of hydroforming. Hydroforming is the process they use for really intricate bike frames. Allows you to almost you make a mold almost similar to a carbon fiber mold, and then you use fluid inside the tube to press it into the outside shape. So it's very simple. It's kind of akin to carbon molding, but you need weaker materials to be able to do that. You need, and it's typically not available in the levels of aluminum that we like to use for handlebars, which in the case of our aluminum one is 7050. A big reason for 7050 is that even though strengths vary significantly between types of aluminum, 7075, 7050, down to like the 6000s, like 6061, or the 2000s, like 2014. Even though the strengths vary significantly by 30, 40%, the stiffness of the base material doesn't move very much at all. 6000 and 7000 are almost identical. 2000 slightly different, but a very, very small degree. So if you add, so what it comes down to is if you add material, you add stiffness.
Okay.
So we made it out of 7000 series. We made it out of 7000 because it gives us the most strength with the least material, and the least material means the most compliance.
Okay. And when you talk about material, it's basically wall thickness, I guess. Is that right?
Basically, yeah, wall thickness. Yeah. Aluminum's homogeneous, so you end up with wall thickness. The other struggle with aluminum is that you typically have a homogeneous wall thickness no matter what you do, which actually works to our benefit because the oval design allows us to have a homogeneous wall thickness to pass our fatigue testing. So at the end of the day, we make 7000 series bars, which are as compliant as they can be while still passing the same fatigue testing and drop test testing that our carbon bars do. But without excess material that would be required if we made it out of 6000 or out of 2014.
Got you. Okay. And how close did you manage to get to the kind of the compliance performance side of the carbon bar with the aluminium side? Because like I say, it's much more of an engineering challenge, I guess.
We got very close on the actual like weighted displacement, call it that. Like if you hang a weight from it and see how much it moves, it's the pure stiffness.
Yeah.
Very close. It's a little bit harder to quantify the damping effect of carbon versus aluminum.
Yeah.
You have to get into resonant frequencies, and that's something that we're starting to do with some new software that we got. But I run both. On my regular bike, I have a carbon bar, and I've always been a carbon bar person. And then on my e-bike, I currently run the aluminum bar, and I actually find the aluminum bar to be more comfortable. Like it's pretty cool. I recommend it.
It would be inherently less damped than the carbon version, though. In theory, is that right?
In theory, yeah. But I don't know what it is about it. I haven't quite pinned it, but I really do like the aluminum bar.
Interesting. How would you direct people then if you were in a shop selling your products and you were talking to a customer? How would you help someone find the best bar for them between the aluminium version and the carbon version? Let's assume they're not on an e-bike.
Yeah. Price and weight, I guess, are the main things that it comes down to, as well a little bit of riding discipline. So if you're more into trail and enduro and you're getting older like I am, I'm now 42, you don't like to fall as much, carbon's the way to go for sure. If it's in your price range, because it saves about 100 grams, I think, over your bike, which is about a quarter pound off your bike. The reason we got into aluminum bars to begin with was because we used to be a team of 3. Now we're a team of 29. And we've always said that we want to make the products that we want on our own bikes. But as the team grows, that breadth of riding disciplines also grows. Like we've got some gravel grinders. We'll probably enter that segment in the coming years. We've got Whistler Bike Park that's 45 minutes away. And if you're someone who's hitting the bike park every weekend, or you're a DH racer and you're clipping trees and you often lay it down, and like aluminum, I don't think it's controversial to say is better at damage tolerance. If you hit a tree, if you hit a rock, it's stronger in that way. So if you're running carbon bars, you take a big ding out of it, you should change that bar. If it's aluminum bar, you probably won't even, maybe you don't even notice a scratch from the same incident. So, and then the carbon bar is half the price as well. So, but feel wise, I think they're very similar. And like I said, I think I even prefer the aluminum.
Yeah, interesting. How often would you suggest replacing handlebars? So aluminium accrues fatigue, right? And at some point will ultimately break. So there's a need there to change your aluminium bar at some point. And I'm guessing that's different in carbon.
Yeah. So carbon is an interesting material because it's almost impervious to fatigue. Like it goes forever on the same fatigue rig that'll break a carbon bar at 300,000 cycles or something. But then aluminum is more damage tolerant to blunt hits and over clamping and things along those lines. So it's a difficult answer. There's a difficult question to answer. There's no hard line. And you should really talk to your local bike shop about how much you ride, what shape your bars are in, and just play it safe. Like if you have a ding in your carbon bar, change it. If you've been running your aluminum bar for, I don't know, 3 years hard, it's probably a good time.
Yeah. And even I guess
there's no hard and fast rule, I guess is what I'm trying to say.
Yeah, fair enough.
It's a hard one to answer.
Hard to pin down, yeah, because you don't know how hard or how much people are riding as well. But I'm guessing any carbon bar, if it's had a substantial knock, even if you can't really see visible damage, you should probably think about replacing it, I guess, because you could have some internal issues maybe.
It can. They're getting quite thick. And bladder mold is improving to allow you to compact thicker sections. But it used to be a concern that if you hit it, you could have a delamination that you can't even see. And then I remember people like on frames, you take a little coin and you'd like knock it. And if you could find a dead, like a spot that has a different sound, then you probably have some delamination. But it is a really hard question to answer.
Okay. But less likely these days with the kind of thicknesses that we're seeing in the products. Yeah.
That's right.
Fair enough. Well, awesome stuff on the bar side. They sound very interesting. I'm kind of intrigued to try a pair because arm pump is something I've been suffering with in the last year or so on the downhill side. So I might have to treat myself to a pair of those. But also exciting is that you guys have got a new dropper post coming up. And I think it will be launched by the time this podcast episode comes out. You've already got one of the more popular dropper posts on the market, I'd guess, with the V2 post.
I like to think so.
Yeah, it's definitely one you see out there a lot, always gets good reviews. How do you go about improving something like that? It's always very hard to take a product that is doing really well and make it better. So how do you, as a business, what do you do? Like, what are the steps you go through to say, right, we've got this V2 post, it's doing great, here's how we're going to make it better, before you kind of set off on that engineering journey?
Sure. One of the big advantages we have is that we sell direct to consumers. We also sell direct to dealers and distribution. But what makes us a bit unique is that we handle warranties directly from all channels.
Okay.
So if you bought our product from Joe's bike shop in South Carolina or something like that, we don't require that you send it back to them and then they send it back to us, and then there's this loss in communication. We prefer you talk to us directly, and we'll sort you out directly because you're our customer. You're not just Joe's customer. So in doing so, we've got feedback on every warranty. I wouldn't say every warranty. Let's call it 90%. 90% of the warranties that have happened on V2 posts, and so we know where the improvements opportunities are on that post. And so with let me back up to kind of our evolution from V1 to V3.
Yeah.
On V1, it was our first entry into the post market. It was a bit conservative on weight. We had a few firsts with that product. We really focused on stack height, which is the distance between the underside of the collar and the rails, because we wanted, if you had a bike you could fully insert this post in, we wanted it to be as short as possible. So that's the first time you saw our trademark drop rail clamps at the top. We called them water buffalo, I think, for a little while, because they have one here, but if you look at it, it kind of looks like a water buffalo's horns the way it hangs.
Thought about it like that yet.
Yeah. So we call it water buffalo. So we introduced that. We introduced a really short mid collar, and those two things combined gives you quite a short stack. And it was the first post that was externally travel adjustable as well, because we understood that we only offer two sizes. If you couldn't fit a 150, maybe we could fix that problem by being able to lower it by 50 millimeters. I think that post had travel on it that you could do externally in a few minutes. So at that time, we looked at what was in the market. We didn't have a lot of experience with dropper posts, but we had a fairly conservative design, as I mentioned. And we focused on the geometry ways that would make that post work better for a product. V2 came around, I think about a year later, because as we started to get feedback on the V1 post, we came up with all these cool ideas that we could do to take it to the next level. With V2, we offered it in more sizes. The V1 was only available in 150 and 170. We understood that people wanted more than 170, and that there's a lot of people out there who couldn't fit our 150. So we offered 120 to 210 millimeters. We dove into the cartridge, and the goal in that one was millimeters, taking out millimeters wherever we could. So I designed our own valve within that cartridge that shortened it to allow us to shorten the cartridge. I pushed the actuator up inside the lower tube when it's fully compressed. There was space between the bottom of the upper tube and the end of the cartridge. So I biased the actuator up inside that free space to make the actuator even shorter. And the V2 had the shortest total length and shortest stack height of any post when we launched it, and it's still pretty darn close. I think there might be one post out there that has a slightly shorter stack, but only by a couple millimeters. And at the same time, we took a bit of weight out. It wasn't the main idea, but we went to an oval upper tube, and we got down to a post that's pretty darn light. Not the lightest in the market, but pretty close. But that had better reliability of the cartridge, refillable cartridge, and everything just shortened into a smaller package. That went on for a few years. And then we expanded the upper and the lower end of that. We'd always planned to extend the upper, so we did a 240 because there's quite a few tall guys here, and the 210s still have this much of the post sticking out of above the seat collar, so there was some room to move it. That required us to make the upper tube a little bit stronger. At the same time, my sister came to me one day because she was getting into mountain biking, and she's like, "My friend went to the store and they say that she's too short to have a dropper post." And I was like, "No way. Get her to use our dropper post calculator. We have this website that they'll tell you what you can fit." And she came back and she's like, "Yeah, she did the dropper post calculator and yours don't fit." And I was like, "Really? No way. Okay, cool. What does she have?" So she had this giant she's quite short, like 5'1", 5'2", something like that. And she had a giant with an interrupted seat tube.
Okay.
So we made a 90. Like I was like, well, we can't have this person out there who can't run our post. We're supposed to have the widest range. We're supposed to fit everybody. So we made one size shorter that fit her. And she ran the first prototype and she was stoked. So that's kind of where we ended up at with V2.
Yeah.
So your original question is what do you do to make a V3?
Yeah. What is the targets that you set out to achieve to get from what is already a well-performing post to something that you believe that you can make that's even better?
Sure. One was reliability. Even though like I said, we have access to almost every warranty claim we've ever received. So we can correlate those and see where, although the V2 is a very high performing post, it still has some issues with it.
Yeah.
And so we set out to fix those. We fixed things like having too much saddle play, like that side to side saddle play that you kind of get on posts.
Yeah.
The V3 has next to none. I won't quite say none because you have to have a little bit of space, but it's very slight. We took a bunch of weight out of every component. And it became a game of millimeters and grams. Can I take 2 millimeters and 3 grams out of the actuator? Cool. Doesn't seem like a lot, but you do that on the actuator and the lower post and the mid collar and the upper and lower clamps. And eventually you're talking quite a bit. Our V3 is 60 to 70 grams lighter than V2. It's the lightest infinitely adjustable post available on the market, lighter than every other infinitely adjustable post on the market. And it runs a lot smoother. One of the complaints with our V2 is that the the seal wasn't the smoothest. It added stiction. It made it more difficult to drop. So we went to SKF and we've been working with them for over a year, or we're working with them for over a year to develop a custom SKF seal, which has significantly lower friction. We worked with IGUS bushings to develop a 3 bushing system. I have one here as well. This is the mid bushing that you typically don't see on dropper posts.
Mm-hmm. Because of like people saving cost? Is that why you wouldn't see that mid bushing?
I think it's just there's not a lot of really long droppers out there.
Okay.
One of the things that you want from a long dropper is larger bushing overlap, which means the distance between the top and the bottom bushing. Mm-hmm. That controls how much the post rocks front to back.
And as it rocks, it's not going to move freely, right?
That's right.
Yeah.
But as you increase that bushing overlap, the unintended consequence is that you actually create a section of the post between those that can bow. Mm-hmm. And if the clearance to the lower tube is too tight, you actually get rubbing between the upper tube and the lower tube. So on our longer posts, on our 180, 210, 240, we've added a mid bushing, which if that happens, it loads the bushing instead of loading aluminum on aluminum, which makes it very slippery on the way down.
Yeah. As you increase the bushing overlap, does that force you to increase the total length of the post?
It does, but I think that's a reasonable trade-off.
Okay.
Because bigger posts are generally ridden by bigger people.
Yeah.
And bigger people are generally heavier. So we want to not give up reliability for the sake of having the shortest total length.
And they're also probably riding bigger frames with more insertion depth, I guess, so you can handle a longer overall length post.
Absolutely.
Okay.
So the V3, it's in a lot of ways a refinement of the V2. The V2 had the same bushing overlap across the board, except for the 240, which we increased, which is what led us to realize how much of a better idea that was. So on the V3, every different size has a different bushing overlap from 90 all the way up to 240. We've also added six anti-rotation pins instead of 3. These brass guys here, if you're looking on Downtime's YouTube channel, the rear left and the rear right, which are these two, are made of plastic instead of brass, and that plastic is oversized, almost so it becomes a compression fit.
Okay.
And that compression fit virtually eliminates any saddle rotation play. And then the brass pins are there to back it up. So if you really torque your saddle, you'll hit brass. But if you are just riding around, it's going to hit those 2 plastic pins. There were only 3 brass pins on our V2 design. Our cartridge is completely new. It's fully aluminum. We've removed any steel to remove weight. So I think we shaved 30 grams out of the cartridge alone.
Fair play.
Yeah. At the same time, we've made it fully recyclable as well. It works a little bit like a CO2 cartridge. So if you remove the top nut, we offer, when you get a service cartridge, if you get a service cartridge, we offer a puncture bolt so that you can actually puncture the top of the cartridge, drain all the oil, and recycle your oil with mineral oil from a fork. And then at that point, the cartridge is 98% aluminum. So you can toss it in with pure aluminum. You can toss it in with mixed metal. But we saved a chunk of weight there. Yeah, just refinements across the board.
Yeah. Am I right in thinking you've got some ovality on the inner diameter of the tubing as well?
That's correct. The upper tube is oval. You remember back to me talking about carbon bars and how when you wanted strength out of a round tube, you want to make the top and the bottom thicker. So we've done exactly that on the upper tube of the dropper post. The front face and the rear face of the tube are thicker than the side faces of the upper tube. So it's a round outer profile, but an oval inner profile.
Yeah, and does that oval profile vary in the different lengths of the post as well?
In this case, it's the same up to 180. And it's not that we couldn't have gotten even lighter, have we made it different all the way down to 90, but you get to a point where it's about the tolerance of the wall thickness, not the wall thickness that you could theoretically achieve. So we found that the profile we have on the 180 is as thin as we want to go for other reasons than pure fatigue.
Yeah.
But then the 210 is thicker, also oval, and the 240 is again thicker, also oval. So those 3 have tubes that are specific to that drop length.
Yeah. Wow. So the actual amount of parts that you've had to design for this new, what is effectively a range of posts, is pretty, you've gone all in, right? It's not straightforward.
Yeah. It's, as you mentioned, it's a very popular post. We want to keep it that way. It's one Vital MTB's next post to buy 5 years in a row. So we want to make it a 6th, and we think this is a significant step up.
Good. And is recyclability becoming more and more important? You mentioned that it was something that you factored in with the cartridge. Was that like, we can do this, so we will, or is there a real drive in the industry now to try and improve recyclability where possible?
I think there is a drive in the industry, and it's not that I'm not trying to greenwash. I'm not trying to say that this is a perfect industry that way. But it's important to try to be able to recycle things where we can. And sometimes it's just knowledge. Like our older post, you could also disassemble and dispose of things properly. But we need to get the knowledge of how to do that out there. So it's something that we have an internal employee who's working on sustainability for us. So we're going to be putting up more, we call them end of life instructions. Mm-hmm. So the product, you're done with the product. It doesn't just go in the landfill. This is how you strip it. This is where these parts go. This is where these parts go. Or you send it back to us as something we're working on as well, so that we can retrofit them. But it's a work in progress. We're not there yet, but we're working hard on it.
Oh, that's really good to hear, man. And what about testing for dropper posts then? What sort of stuff are you doing? Both sort of lab rig-based testing and then ride testing?
Ride testing is again, rig-based testing is where we start. We don't ride test things until they've passed our requirements on the rig. We have internal testing here in Squamish as of about a year and a half ago. So we've got standards that we want to have posts meet before we allow our riders to get on them. And then once our riders get on them, it's really about feel. It's about smoothness. It's about longevity of seals and whether grease got in or grease got out or water got in, those types of things. It's not really about end of life or fatigue testing. Just more about how does it feel under the rider. Mm-hmm.
And then in the lab, are you doing like accelerated wear testing? Have you got posts constantly just going up and down all day? How does that work?
Not so much up and down. We not here anyway. We do cartridge testing in Taiwan, which is where most of our manufacturing is. But here it's about fatigue testing that could have a post break in the field. So we have fatigue testing cranking on these things quite often.
Yeah. Yeah. So you've got all this engineering that's gone into it. You've been eking weight out here and there, which is adding in, I'm guessing, kind of machining operations and surfaces and all this kind of stuff. You've got a huge, I guess, bill of materials across the entire range to try and make sure that every length post is, perfect for everybody. But all this comes at a price, and I'm sure there's a price target involved. Like, how do you work towards a price target and decide when to kind of factor things in or take them out and get to a price that you're happy for this thing to go on the market at?
That's a good question. We've always, it's a bit of a strange thing. This company was started by 3 engineers, and we've always kind of wanted to sell things for a fair price, but then also make decent margin on them. So like, we've never designed a product and said, this product is really good, so we can sell it for this. It's more been like, this product cost us this, so that lets us sell it for this.
Yeah.
We want to sell products that we would want to buy with our own money, that makes sense to buy with our own money. We want it, at the end of the day, if you take a look at the specs and the price, I want it to be the logical decision for somebody to buy our post. So they say, well, that post weighs this and it only costs that, and it's available in all these sizes. Why would I buy anything else? If we can achieve that, I think I'm pretty happy with our company.
Yeah. And has that been challenging to do when you're going to all these, like, to the nth degree effectively to make the product kind of so unique in its performance and its ability to suit all different sizes of riders?
I don't think so. I think you run that calculation and we still come in quite a bit lower than a lot of posts on the market that I don't feel are as good as our post. Uh-huh. So there seems to be room, I think, I guess, to answer your question a bit vaguely, to sell it where we want to sell it, and then also still be cheaper than a lot of the posts on the market.
Yeah. Good position to be in. What are you most proud of then from that development? Because that sounds like it was a pretty big project.
It was pretty big. It took 3 years, which was the longest project that I've worked on here at OneUp as a single product. Probably two things: the weight. I think being able, anytime you can put an est on the end of your selling feature, the lightest post on the market, I think that's a feather in my cap.
Yeah.
And for us to be the lightest, infinitely adjustable post on the market, I think that's a huge win. I think from an engineering standpoint, I think I love how simple this thing is to tear apart. You only need a 2mm hex, a 5mm hex, and a 14mm wrench. And the only reason you need a 14mm wrench is to be able to remove the actuator because it has flats across it.
Okay.
But we ended up at that dimension because it happens to be the dimension between the side plate and the custom tool on our EDC tool. So at the end of the day, you can disassemble this entire post using only an EDC tool.
Nice. So if you've got an EDC tool in your stem, job done.
That's right. So you can take out every bolt from this post, turn it into a pile of base parts using only an EDC tool, which I think is pretty cool.
Yeah, that's nice. I like that. Elegant. Nice engineering. Yeah. Good stuff. So what is the retail price that it's ended up at?
The retail price, I believe, is $279 US dollars.
Yeah.
And I don't have the euro and the UK conversion on that.
That's all good. Nice.
Yeah.
Good stuff, man. So I'm guessing now that the post's kind of out there, there's other projects bubbling up. Is there anything else that you can tell us about that's coming up? Anything you can tease us with? Perhaps you mentioned that there might be some forays into the gravel world, but
we're certainly looking at gravel parts. We're testing a few different things. I can't really get too deep into new products that we're working on, unfortunately. I will say that I'm not done with this dropper post. I have some ideas on some extra bits, some extra kits that we can use with it.
Like add-on kind of things, like
potentially, potentially add-ons.
Okay, interesting. Yeah. I can't think of any examples of something like that in the market, so I'm kind of intrigued as to where you're headed with that.
Yeah, it'll be cool, I think.
Yeah,
it'll be cool.
Excellent.
Yeah, we're always looking at the electronic side of things as well. It's not one of our traditionally one of our core competencies here, but we see the market going that direction.
When you say electronics, are you thinking more like the wireless side of things? Is that what you're kind of talking about?
Yeah, I think SRAM has done an amazing job on their drivetrain, on transmission.
Yeah.
But Axis is pretty cool. It offers you some advantages that you can't have with the mechanical system. But on the Drop Pro side, I haven't seen a wireless dropper that doesn't come with compromises, significant compromises in weight, stack height, total length, all the things that you need a post to do. There's not really been a wireless solution there. So it's something that we're looking at as well.
Yeah. Interesting. Okay. And what's exciting you then in the mountain bike world at the moment? Like there's a lot going on. There's a lot of kind of negative vibes floating around. There's a lot of brands struggling. We've seen some pretty sizable companies and some small companies disappear or go into administration, but racing's as exciting as it's ever been. There's a lot of positive stuff there. There's loads of great technology. Like how are you feeling about things?
I'm excited about DH coming to the forefront again. It kind of was before Enduro, and then Enduro kind of took over as the main racing scene for a long time. I think I'm pretty excited about DH coming back to the top of the game as well. I'm sure it has been there has stayed there for a lot of people, but for me, I'm coming back to it.
Do you feel like the downhill following is going to grow then? Is that the way you're looking at it? I think
so.
Yeah.
Yeah. I think the downhill following will grow in the next few years.
And is that a byproduct?
I'm excited about e-bikes.
Sorry, I was just going to say, is that a byproduct of the coverage, or is it just that like it's a super exciting sport that is just getting more interesting to watch? Like what do you think's driving that growth in that area?
I don't know. Honestly, it seems to come in waves. I remember it was huge, and then it kind of took a back burner to Enduro, and now I feel like it's coming back to the forefront again. I don't really have a good explanation of why, but
Yeah, it's fair. I hadn't thought about it, but it does feel like
maybe not even from the racing side, but I think from the participation side. Like as I mentioned, we've got quite a few people here, and I've seen more DH bikes show up last year than I had in the previous 9. So
yeah, interesting.
It's certainly getting some attention from us locally anyway.
Yeah, that's cool.
I think e-bikes are going to get lighter. They're going to get more like regular bikes with the addition of a motor. I think that's going to continue to. It's pretty exciting to see anything that brings that much change to the industry. Yeah. It's exciting to watch it develop. I think the early ones were a bit janky to ride, but you ride some of the newer ones and they're pretty good.
Yeah, definitely.
As a bike to ride downhill, not just a bike to ride uphill. So I'm pretty excited with that. Yeah. That continuing to move.
Yeah, definitely. What are you riding at the moment? What's in the garage?
I have a Santa Cruz Mega Tower. And I have a Santa Cruz Heckler SL.
Okay. Oh, how is that? I've not had the chance to ride one.
Yeah, I love it. I love that the Fazua motor, when it's off, you can pedal through it. So it's very close to being a one bike. That's what I think is very cool about that Fazua system, because if you pull the battery out, you've got the biggest storage container in the world, and you don't have any motor resistance. So it comes at a pretty small penalty. So it's a cool bike.
Yeah. And how's the range like when you're using the motor?
It's good for around here. I don't do epics on it by any means, but if like I said, if I do run out of battery, at least I'm not pedaling through a motor to get home. Yeah. So it's good. It's not up to the full range of the big guys, but
yeah. Interesting. Anything on the wish list? Is there stuff that's launched recently that you've kind of been looking at and are intrigued by, not necessarily to own, but you would like to swing a leg over and try?
I've always loved the look of the raw Madonnas. I don't know why. Maybe it's just like the pure like utilitarian look of them. But I understand they ride quite well.
And they've just launched a V3.
Yeah. They definitely look the part.
Yeah. And the downhill bike, to be fair, the Yala looks, again, similar thing. I think it's just that raw, clean finish. Like, it's an elegant looking piece of design, I think.
Yeah.
Nice. Yeah, I would definitely like to ride those. Cool, man. Well, it's been interesting catching up. I'm excited to see how the new post goes down in the market, and hopefully there'll be some more awards winging their way to you guys over at OneUp. If people are interested to find out a bit more, where's the best place for them to be looking?
Yeah, hit us up at oneupcomponents.com, Instagram, Facebook, we're everywhere.
Nice one. We'll stick links to all of that in the show notes. But yeah, thanks, Jon. It's been a pleasure catching up. All the best for the next year, and we'll look forward to seeing what else comes our way from OneUp.
Great. Thanks, Chris. Appreciate it.
Nice one. Cheers, Jon.